Alright guys, welcome. This is the study guide. Let's get started. Alright, so to evaluate, we want to evaluate the top first and use parentheses. So 9 minus 2 is going to be 4 times 7. And then we can evaluate the bottom separately. 7 times 8 is 56. And then 4 times 7 is 28, so you get 28 over 56, and then you just want to evaluate that by reducing, and so you want to see what number goes into both. You can also divide in your calculator, and this would actually be 28 goes in both of these, so you can divide by 28, and that becomes 1 over 2, or 1 half. Evaluate the expression here. Again, start with the inside the parentheses. 4 minus 9 is negative 5. Do our exponents, which is 25, and do our division. 18 divided by 3, which is 6. Bring down the signs. Again, that's following PEMDAS. Okay, so we do parentheses, exponents, multiplication, division, then addition, subtraction last. So notice I did parentheses first, exponents, did the division, and now I'm going to do all the combined like terms. So 25 plus 6 is 31. Minus a negative 5, that becomes positive, that should become 36. Now if we square something, it means multiply that base number to itself that many times. So this would be negative 5 times negative 5, versus this one down here, I'm only squaring the 5, so there's a negative on the outside, and then I'm squaring the 5. So this one's negative times a negative, so I'm going to end up with a positive 25. This is a positive times a positive, and then times a negative, so that's a negative 25. A little bit of a difference there. All right, here we just plug in. So instead of x, we're going to plug in 22. And instead of y, we're going to plug in 7 and then divide by 3. And so we just do 22 minus 7, which is 15. And 15 divided by 3 is going to give me 5. All right, evaluate the expression. So again, we're doing the same thing. So I like to just kind of go ahead and set myself up. I'm going to put in my parentheses. X is going to go in for 3. And y is going to go in for negative 2. 3 times 3 times 3. That's going to be 3 times 3 is 9. Times 3 is 27. So this will be 27 times 10. And then negative 2 times itself. That's going to be positive 4, and then 4 times 4 is 16. So basically all those values, we can multiply this by each other in our calculator, and we get 4,320. All right, next page. So we want to combine like terms here, so we look for our like terms. You can use a highlighter or something like that. So I have a highlighter here to use for one of them. So we have our x's, we have our cubes, right? And we have, let's see here, the y's. So I'm going to put the biggest exponent first, which is x cubed. So that's 3 plus 1, 4x cubed. And then I'm going to go alphabetical order. So x would be next. X squared, 3x squared minus 8x squared, that's going to be a negative 5x squared. And then negative 10 and a positive 5 is a negative 5y squared. So you kind of want to go in that order. Again, it will be multiple choice on the test, so it won't matter as much. Combine like terms. First, I should distribute. That's 8x plus 40 plus 3x minus 10 plus 10x. Then we combine like terms. I get 8x, 3x, and 10x. And then the other ones are 40 and negative 10. So that's going to give me 21x, and that's going to give me positive 30. So distribute and combine like terms. So distribute, we get 5x squared plus 30x, and 5 times 8 is negative 40. This is just going to distribute a negative all the way through, so we basically just change the signs of everything. And same here. We're going to change the sign and multiply by 3. So negative 3x squared, that becomes a positive 3 times 8, 24x. And we go through it. We get 5x squared, negative 3x squared, negative 3x squared. We get 30x 6x and 24x, and negative 40 and negative 17. So these are going to add up to negative 6x and a 5x squared, so that's going to become a negative x squared. Then with the red, I get 30 plus 6 is 36, plus 24 is, I want to say 60x. And then negative 14, negative 17 is negative 57. And we don't factor anything, this is just the first chapter, so we're just combining like terms. Later on we can do that. But not yet. Solve the equation for x. We get negative 7, negative x equals 2, so we're going to get rid of the 7 first. So I'm going to add 7 to both sides. And my screen's going to go dark. So I get negative x equals 9, and then I have to divide by negative 1, so x equals negative 9. Here again, we're going to add the 19, and 35 plus 19 is 54, so we get 54 equals 3x, divide by 3, and x equals 18. You can hear me use my calculator just to be double sure. You can use the calculator on the test. All right, distribute. So we get 8x, and then 4 times 9, which is negative 36, and then 6 times 10x is 60x, and 6 times negative 6 is 36. Now we want to move the smaller variable, so we got 8x and 60x. I'm going to move the 8x. That's goodbye. We get negative 36 equals, that's going to give me 52x, negative 36, add 36 over. That goes to 0. Now, that doesn't mean it's an insolvable problem. It just means that when I divide by 52, I get x equals 0, which is perfectly fine. No problem. Okay, 2 sheets down and a lot to go. So let's keep going. All right, now we got to distribute by a fraction, which is super fun. So we distribute by a fraction. It's really just like multiplying by 3 and then divided by 4. So 8 times 3 is 24, and then divided by 4 is 6, so it's negative 6x. This one, if we divide by 4 first, we get 1. 1 times 3 is negative 3. Kind of makes it a little bit faster. Add 6, we get negative 6x equals 9. Divide by negative 6, and we get x equals 9 over 6, that's negative, but we should be able to reduce that to a negative 3 over 2. Distribute and solve. So we distribute, we get negative 8x, negative 6, negative x, positive 7, and 46. Combine like terms, negative 8 and negative x is negative 9x. Negative 6 and plus 7 is plus 1. We're going to subtract 1 to get negative 9x equals 45, and divide by negative 9, x equals a negative 5. Ain't that convenient? All right, 15. So when we're doing 15, again, distribute at negative 2. So we got 23, negative 10x, negative 18 equals, sorry, and then distribute the 5. We get 10x and 55. So we're going to combine like terms. First over here, so we get 23 minus 18, that's negative 10x plus 5, and 10x plus 55. Now, smaller is the 10x, so I'm going to add 10x on both sides. But I can do 2 maneuvers at once. If I'm moving the x over here, I want to move the 55 over here. So if I do that, I get 20x equals a negative 50, and then we can divide by 20. And that's going to give me x equals negative 5 over 2 or negative 2.5. That depends how you want to write that one. But they both work. Number 16, we want to get that 8 out of there. So we can multiply by the 8. Whatever I do one side, I have to do the other, so that cancels that out. I get 5x minus 3 equals 4 times 8, which is 32. Add the 3, and we get 35. 5 goes into that, I believe, 7 times. Let me double check. Yes, it does. and 17. Distribute yet again. We get 2x minus 2 times 4, which is 8x, times negative 3 is a positive 6 equals 6 minus 6x. Combine like terms here, I get negative 6x plus 6 equals 6 minus 6x. And here, they're both the same, so we're going to get into some trouble. Because once I add 6x over here, and 6x over here, they cancel. End up with 6 equals 6, which is true, which means, what's my answer? All real numbers is my answer for x. So any real number I plug in for x, it's going to work. Whoa. Okay, so that's pretty cool. All right, 3 down. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh gosh, we're not even close. And 10, 11 to go. Oh my gosh, I'm sorry guys that I did this to you. I'm also doing it to myself, so there we go. All right, distribute. It's like if you didn't know how to do the last one, how are you gonna do this one? You know what I mean? All right, so negative 20x, negative 4 times a negative 7 is a positive 28 plus 2x equals, and then distribute, negative 2 times 9 is a negative 18x, and that is a negative 10. All right, combine like terms on this side, we get negative 18x plus 28 equals negative 18x minus 10. So again, we see that the variable is the same coefficients. When I add 18x, we get them to cancel out. But this time we get 28 equals negative 10, which is false. That does not work. So this is no solution. Okay, so there's the two differences right there. All right, cross multiply. So some of you did this like cool little butterfly thing. But basically we get 8x equals 3 times 40. And so 8x equals 120. And 120 divided by 8 is x equals 15. We could do it again, and in fact we can do it 2 more times. Make sure here we write it out because we're going to have to distribute. So distribute, we get 5x minus 5 equals 3x plus 3 times 9 is 27. Let's subtract the 3x. To get 2x. And then if I add the 5 over, which I'm kind of running out of room, so we'll be right over here. I get 32, and divide by 2, x equals 16. And we do it again. This time we get 7x equals 3x minus 8 times 3 is 24. So I did that one step. I'm going to subtract the 3x. To get 4x equals negative 24. Divide by 4, x equals a negative 6. All right, absolute value. So absolute value, the key is to get the absolute value part alone, and then we set up our 2 different cases, one where the value is equal to is positive, and one where it's negative. Remember, this always has to be equal to a positive value first. We check that out, and that works. So we get our case 1, case 2, x minus 1 equals 6, x minus 1 equals negative 6. Okay, so we're going to get 2 answers for this. Add 1, and x equals 7. Add 1, and x equals negative 5. So we get 7 and negative 5. Over here, we have to get the absolute value part alone, so we're going to divide by 2 first. Get x plus 8 equals 10. Set up my 2 cases. So we equal 10, and it will equal negative 10. So I subtract the 8, and I should get x equals 2, and x equals negative 18. All right, 4 down. What did I say? It was a total of 14. Oh my gosh. So we're not even halfway. All right, here we go. Distribute. No, don't distribute. I'm sorry. We want to get this along. Almost caught myself. So we have to get rid of the 2 first. We get negative 45. And then divide by negative 5. So we get 6x plus 15 equals 9. That's possible. That absolute value could come out as positive. So we're going to go ahead and do our cases. Case 1, case 2. So we get 6x plus 15 equals 9. And 6x plus 15 equals negative 9. Because if I put a 9 or a negative 9 in here, they'll both come out as 9. So I'm going to subtract the 15, which will give me negative 6, which, if when I divide, will give me negative 1. Here I subtract 15, and this time I get a negative, let's see, 24. When I divide, I get a negative 4. And my screen went dark. Oh man, I hope you didn't miss all that. But there it is. Case 1, subtract 15, get negative 6, divide by 6, I get negative 1. Subtract 15, I get negative 24, divide by 6, I get negative 4. Those are my 2 values. Alright, let's go into inequalities. Okay, so we solve for x like normal. The only time is when we do anything different is we flip the sign if we divide or multiply by a negative. So everything else is the same. So distribute, we get 2x and negative 8, x plus 3. I'm going to go ahead and move the x over, so I'm going to subtract the x. Again, I can subtract, that doesn't change my sign. So I get 3 less than or equal to x minus 8, add the 8, and I get 11 less than or equal to x. Okay, so interval notation and graphing. So first of all, I'm just going to put 0 here. Actually, you don't even need to really put 0, but it doesn't matter. I'm going to put 11 here. I don't care about the spacing. It has a bar, so we're going to fill it in. And then if you read this, 11 is less than or equal to x. I like to read it in the position of x. X is greater than or equal to 11. So it's open bigger, so x is bigger than 11. So I'm going to go ahead and go in that direction. Once you have the graph, it's actually easier to write interval notation. So we put a bracket when it's equal to, so we can equal 11. And then it goes on for infinity, and we put an open parenthesis. Okay? So it looks something like that. We'll do this again and again. Add 4. So we get negative 2x is greater than 14. Now we divide by negative 2. That means my sign's going to flip. Okay, so that's important. There we go. I flipped sign. And we get negative 7. So I'm going to go put 0 here, negative 7. It's open. X is less than, so it's smaller. So we graph towards the smaller values. That means I have to start my graph with smaller values. So I'm at negative infinity. I go all the way up to negative 7. Now I don't put a bracket like I did before, because open circle, I just put a parentheses. All right, 27. Distribute. You get 3x plus 3 plus 11, and then this is negative 2x minus 26. Okay, combine like terms, and I'm going to move this over at the same time. Move that over, so I get 5x plus 14, negative 26. I'm going to subtract the 14. That's going to give me negative 40. And divide by 5, I get x is less than negative 8, which I was supposed to put interval notation there, but that's okay. 0, negative 8. It's an open circle because it's no equal bar. And it's saying x is less than, so I'm going to graph smaller. Interval notation is going to look a lot like this one, except for with negative 8. Okay. Next, just more distributive property. Okay, so distribute. So we get 3x plus 8x plus 4. Distribute, we get 12x plus 2. Combine like terms, and I get 11x plus 4. Subtract the 11x. At the same time, since I'm moving the x's over here, I'm going to move the 2 over there. Okay, so then I end up with 2 is less than or equal to x. So plot 0, plot 2, close circle this time. And one of the ways you can check to see if this is true, you can pick a point over here and say, is 2 less than 5? Right? Is 2 less than or equal to 5? And that's true, so you should probably graph towards that. So x is greater means I'm going to go towards the bigger values. But you can also just plug a point in and say, does this work? And so when we're starting at 2, bracket, going to infinity, and beyond. All right, 5 sheets down, I think. All right, write an inequality to represent the graph below. So we're going to go bracket at -5, and we're going to go all the way up to 3 and open parentheses. Easy. Okay. Now this next one is a double. So the double, you start with negative infinity. I go all the way up to -1. Again, no brackets on this one. Union, and now I do bracket 3 all the way to infinity. Okay, so we're going to now start seeing some of these double type of intervals here. Okay, and so our first one we see right here. Basically, I want to just get this part to be x by itself, so I'm going to subtract 4, but I have to do it to all sides, so I get -9. 3x is now in there, and 15, that's positive 15. Divide everything by 3, and I get -3 is less than x, and that is going to be 5. So basically this means x is bigger than -3, but it's smaller. So the way that you would write this is literally just go -3 and go to 5, open circles, and graph inwards. This is an AND problem. And I used to do like the hand signal where it would overlap like this, and I'd be like, AND. So this is AND. And so we're just going to do from -3 to 5, and open parentheses on both. So this next was an OR problem I used to teach you to do like this, right? Do a little OR hand signal. So you solve these individually. So subtract 8, divide by 3. So that's our first one. And then this one we're going to subtract 5. So we're going to do 1 and 6. Now, since it's an OR problem, we kind of already know they're going outward, but just double check. 6 is greater, so it's going to go that way. This is less than, so it's going to go that way. So we're going to start at -infinity, go all the way up to 1 and include it, and then we're going to go skip to 6 and go to infinity. So that's how we'd write the OR problem. Okay. Now we get into absolute value inequalities, which are a hoot. We add 5, so we get greater than or equal to 13. And we ask ourselves, can a positive value be bigger than 13? That's true. So we're going to go to our 2 cases. So we do the exact same thing with the other thing as we do basically the same equation. And then case 2, we do the same equation, except where we flip the sign and change the positive to a negative value. Okay, and then we subtract the 2, we get x is greater than or equal to 11. Over here, x is less than or equal to -15. So we get our 2 values, -15 and 11. And essentially we kind of know what's going to happen, but x is less than or equal to -15, so it's going to be a closed circle going backwards. X is greater than or equal to 11, so it's going to be a closed circle going forward. And again, we go from -infinity up to -15, include it, to -15. Union, I start at 11, and I go to positive infinity. Just like that. Okay, I think we're 6 down. I don't know. I don't know if we're going to make it this whole thing or not. We'll go till we can't go any longer. All right, so here we're going to add 6. That's 30. And then divide by 3. So we get 2x minus 4 is equal to 10. Okay, so again, same thing. We just write our 2 cases. So we write it the exact same way we see it without the absolute value. And in case 2, we write it by switching the sign and changing the positive value to a negative value. Okay. Over here, we're going to add 4, divide by 2. Over here, we're going to add 4 and divide by 2. So we got -3 and 7, both closed circles. Okay. And we get x is less than or equal to 7, so it's going to be going this way, and -3 is greater, so it's going to go this way. So this is an and problem, and we get -3 in brackets and 7 in brackets. It's a little easier to graph. All right, unit 4, is this relation a function? So remember, for every x, there can only be one y. So I'm just checking, is there a repeat in the x's? No, so they all have their own x's, so that's a yes. The domain is my x values, so that's going to be 1, 2, 3, and 4. My range is my y values, so that's going to be 5, 4, 3, and 2. Okay? All right, is there any repeat in my x's? Let's see. Okay, so right here, we have 10 twice, and we have 2 different y values, so that's no bueno. So the function, no. Okay, every x value can only have one y value. Okay, so that doesn't work. My domain is 10, 7, I already got the 10, and a 9. My range is 8, 7, 3, and 6. So again, my x, my y values. Okay, so is this a function? We do the vertical line test. I take this, and does it hit more than once? And I would say no. Now my domain is my x values. And since this is going outwards forever, it's going to hit everything. So it's going to be -infinity to +infinity. Now my range only goes from -2 up. So I'm going to go -2 inclusive all the way to infinity. And that's my y and my x values. And then is this a function? Again, I can do the vertical line test, and it passes. Yes. My domain goes from -4 to 3. So -4 to 3. And those are brackets, I'm sorry. And my range goes from -2 up to 5. And those are also brackets because it exists there. Those are closed circles. I don't even know how many papers we're down yet. But we got to be halfway because there's 70 problems. We're at 39. I think we're doing good. Okay, maybe 2 more pages. I think this is going to be a 2-parter. Okay, let's see. What do we got? Domain and range again. Function. Notice when I do a vertical line test, if I draw a vertical line through here, I hit twice. That's a no-go. So that's not a function. Domain. It looks like it's going from -1 to +5. Brackets, and my range is going from -4 to 2. Okay, f of x. So f of x means I'm just plugging this value, -1, in for x. That's all. So we're going to get 3 times -1 plus 12. That's -3 plus 12, which is going to give me 9. So the f of -1 is 9. That's kind of how you'd write that. All right, we're going to do this last one, and then we'll probably call for this video. All right, so we're going to plug this in. So it's going to be 2 of 3 minus 7 plus g, which is 3 minus 2 plus 5 minus 2 minus 9. So not very difficult, just a lot to work with. So 2 times 3 is 6. This is going to be -6, -10, -9. And then you just combine all those values. 6 minus 7 minus 6 minus 10 minus 9. I use the calculator just so I don't make a mistake. So f of x plus 1, so I just take the f of x piece and I just instead plug in x plus 1. And so I get 2x plus 2 minus 7. So that's just going to be 2x minus 5. And yes, you can get a value like that. If there's an x in there, you're not going to be able to solve it. So these ones where they're embedded inside of each other is a little bit tricky. So I first have to do this guy first. I get 2 times negative 3 minus 7. So that's eventually going to be just all of this that will plug in for g of x. So that's going to be 2 times negative 3 is negative 6 minus 7 is negative 13. So I'm going to plug in negative 13 in for g of x. So for g of x, I get 3 times negative 13 squared plus 5 times negative 13 minus 9. Just for simplicity, I'm going to put this into the calculator really fast. And we should get our answer of, I'm just showing you that I got it all in there, 433, which is a pretty large number, I'm going to have to say. Not too bad. All right, g of x just means I'm going to put x in, which we already have. So you just get 2 of minus 7. I put all of g of x in there, which is 3x squared plus 5x minus 9. So I double that, so I'm going to get, and I can do this at once, 6x squared plus 10x. This is the only part that's a little tricky. 2 times negative 9 is negative 18 minus 7, negative 25. Done. Don't have to solve. If f of x equals 5, find x. So this is where I just remove the f of x and do 5 equals 2x minus 7. Add the 7 across. Of course, we're going to get 12. Divide by 2, x equals 6. So that's when f of x would equal 5. Okay, we will finish up next time.